Okay, geometry. In the last section, we talked about the circumcenter and the incenter. Just to recall that the circumcenter was found by finding the perpendicular bisectors of each side and finding their intersection point. And then the incenter was found by finding the angle bisectors and finding their intersection point. So what we're going to start off today is we're going to find the triangle median. And the triangle median, let's say that I have this triangle here. Let me move it up a little bit. And I'm going to go ahead and label it. What we want to do first is we want to find the midpoint of each side. So again, we're going to have a little human error here. We'll see how it works out. And then what we want to do is we want to connect the opposite vertex to that median. So A is going to go opposite to BC. B is going to go opposite to AC. Oh, I did pretty good. And then C is going to go opposite to AB. Put my little lines on there to make that accurate. And what we have just found is the median of triangle ABC. And we found it by connecting midpoints to opposite vertices. As I look at that, my English is horrible. Probably I should write just a little bit better. The median, and I know I said it a little bit different as I was doing it, but the median of triangle ABC is found by connecting the midpoints to their opposite vertices. And I don't want to forget that although this is labeled as the median, the actual point, I don't want to do that. The actual point is called, and that's going to cause me to erase this right here. The actual point is called the centroid. So if they ask you to locate the centroid, that's actually what they're doing, finding the median. So now let's take a look at altitudes. And remember that altitudes are drawn perpendicularly because they are a height. So if I wanted to find the altitude of, let's say, side AB, then that altitude would be drawn from vertex C, and the key would be, where am I going to get a 90-degree angle? Not here, not there, getting a little bit closer. So I would say my best human error would be right there. So that's a little, that's a pretty simple example. What if we looked at an obtuse triangle? It looks something like this. And we labeled it ABC. I think I keep doing those differently. Sorry about that. I'm going to fix that. ABC. And what if I wanted to find the altitude of let's say, the altitude of CB? And so it would have to go to vertice A, and you'll notice anywhere I go, I'm not going to get a 90-degree angle. So what I have to do is I have to extend CB, and then to find the altitude, now I can drop it straight down and get a nice 90-degree angle. So altitudes are not always located inside of our triangle. And so that brings us to our final kind of construction. We're going to create an orthocenter, and all kinds of new words in the last couple of lessons. So an orthocenter is what's going to happen when we get all three of our altitudes to intersect. So there's A, B, C. Obviously the easiest one is going to be from vertex A. So I'm going to go ahead and draw that one. It's just going to come straight down. If I can get a good, I still don't even like that. There we go. Okay, so there's one. Then I'm going to draw from C to AB. I'd call it right about there. And then from B, that's pretty good for the first time, to AC. And all of these, again, would be altitudes, so they are perpendicular. And then that intersection point is called the orthocenter, which is the intersection point of all three all three of the triangles altitudes. Orthocenter is the intersection point of all three of the triangle's altitudes. So that brings a close to Chapter 6, Section 3, Medians and Altitudes of Triangles.